All right, welcome. In this explainer, we're going to tackle something pretty cool. How to take this relentless flow of raw data and turn it into something genuinely useful, in real time. We're going to explore exactly how Kafka Streams manages state to make sense of information that's constantly on the move. So, let's get into it. So, here's the big question, right? What do you do with data that just never stops coming? This isn't about querying a static database. This is about building a living, breathing understanding of data that's always in motion. So, how on earth do we do that? So, here's how we're going to break it down. We'll start with the basics of Kafka's data foundation, then talk about structuring that data. Move into the fun stuff like real-time aggregation and joining different streams. And finally, figure out how to get that one clean answer at the end. Okay, first things first. Before you can build anything cool, you have to understand the foundation. And for Kafka Streams, that all starts with how Apache Kafka itself actually stores your data on disk. Now, this is a super important distinction to get right. We always talk about sending data to a topic, which is kind of like a category or a label. But under the hood, what's really happening is Kafka is writing that data to a partition. That partition is the actual physical file on disk. And this picture just makes it so clear. See that? A topic called purchases with 3 partitions isn't some magical, abstract concept. Nope. On the server, it's literally just 3 separate directories on the file system. That's it. The partition is where your data actually lives. All right, so we know our data lives in these partitions on disk. But what is that data? As far as Kafka is concerned, it's just a bunch of bytes. So let's talk about how we bring some order to that chaos. And this right here is the fundamental problem we have to solve. For Kafka to be crazy fast and flexible, the brokers don't care one bit about your data's format. To them, it's all just raw bytes. But for us, as developers, trying to work with a stream of random bytes, that's a nightmare. We need nice, clean, structured objects. So how do we bridge that gap? Enter the schema registry. Think of it as this central source of truth, a rulebook that defines the exact structure of your data. Without it, you're flying blind. Your producers could start sending data in a new format and boom, your consumers break because they have no idea how to read it. The registry makes sure everyone's on the same page and lets you evolve your data structure over time without blowing everything up. Okay, so our data now has structure. This is where things get really fun. We can now do our very first stateful operation, turning this endless stream of individual events into a running summary that's always up to date. Imagine you're watching a stream of stock trades. For every single transaction that flies by, you want to know things like, what's the total volume this customer has traded today? Or what's the highest price they've paid for this stock? That's aggregation. We're continuously updating a summary with every single new piece of information. So how does Kafka Streams pull this off? Let's look under the hood. Step 1 is simple. The raw events, our key value pairs, just flow right into the processor that's going to do the aggregation. Okay, now pay attention, because this is clever. The processor does 2 things at once. To keep things super fast, it calculates the new total and immediately forwards that result downstream to the next step. But at the exact same time, it sticks that result in an in-memory cache, so it's ready for the next calculation. You get speed and fresh data. Right, but what happens if the application crashes? That in-memory cache would just vanish. Well, Kafka Streams has that covered. Periodically, it flushes that cache, writing the state down to a durable state store on disk. It also rates it to a special changelog topic. This gives you complete fault tolerance. If your app dies, it can restart, read from that state store, and pick up exactly where it left off. No data loss. Now, when you're aggregating a k-table, which, remember, always represents the latest value for a given key, the logic is really smart. Let's say a customer's total changes. You can't just add the new value to the grand total. You first have to subtract their old value and then add the new one. It's this beautiful little adder and subtractor dance that keeps the aggregate perfectly accurate. And really, if you're coming from a database world, this will feel very familiar. The group by in Kafka Streams? That's your SQL group by clause. That whole adder/subtractor logic? That's basically a sum or count that's running continuously. And the resulting k-table, the thing that holds our state, you can just think of it as a materialized view that's being updated in real time with every single event. Okay, so we can summarize data, but data rarely lives in a silo, right? It's way more powerful when you combine it. So next up, Let's see how Kafka's streams can enrich events by joining different streams together, all in real time.
So to get a handle on joins, picture this. On the left, you've got a stream of customer purchases coming in. On the right, you have a stream of customer promotions. Each of these streams has its own little processor and its own local state store, which is just holding the latest info it's seen for each customer.
All right, now watch this. A new purchase comes in on the left side. The processor grabs its key, let's say it's the customer's ID, and it immediately does a lookup, but not in its own state store. It looks across to the other processor's state store. It's essentially asking, hey, do you have any promotion info for this particular customer? And if it gets a hit, if a match is found, a special joiner function kicks in. This little piece of code takes the purchase data from the left and the promotion data from the right, mashes them together into a single, new, enriched record. And then that new combined event gets sent on down the line for whatever's next. Okay, we're almost there. We've aggregated our data, we've joined it, and we've created this constant stream of updates. But what if you don't want to see every single intermediate step? What if you just want the final answer? That's what we're tackling next. Just think about it for a second. With every single new event that arrives, our aggregation or our join spits out a brand new result. That can be incredibly noisy, right? Sometimes you don't care about the journey. You just want to know what the final result is after all the activity for a certain key has died down. Well, Kafka Streams gives us a tool for exactly this, and it's called the suppress operator. Its job is to hold back the output, to not be so chatty. But it gives you a trade-off. You can go with a strict mode, which will wait until a time window fully closes, guaranteeing you get just one final result. But that could use up a lot of memory. Or you can use an eager mode, which might send the results out early if its memory buffer starts to get full. And this really gets to the heart of the decision you have to make as a developer. What's more important? A guaranteed 100% final result, even if it means you risk running out of memory? Or is it more important to keep your application stable, even if it means you might occasionally see a few intermediate results? There's no single right answer. It completely depends on what you're trying to build. So look how far we've come. We started with just raw, meaningless bytes sitting in a partition. We gave them structure, and then we used that structured data to build these incredibly powerful stateful operations, like aggregations and joins, all happening in real time. We now have the fundamental building blocks to pull amazing insights out of data the very instant it's created. So the only real question left is, what are you going to build with it?